Hi, this is Karen O'Brien, and I wanted to talk about levees with you, doing a series of levee videos with QGIS. I just do a kind of a quick little project overview. This is a micro model. I took a micro model of a project called the Middle Rio Grande. The Middle Rio Grande is a 250-mile model from Cochiti Reservoir to Elephant Butte along the Middle Rio Grande Valley. And it was a model that was kind of like created by a collection of authorities or a collection of people like the Fish and Wildlife Service, the United States Army Corps, the BOR, I think it was the World Wildlife Federation, the International Boundary and Water Condition, and the irrigation districts. So there's several irrigation districts in New Mexico that use these, that wanted to be collaborate on these projects as well. So what we hope to create through this is a living model of the Middle Rio Grande that can be used by all of these people to study what would happen with specific releases, what would happen with specific flood events, what would happen with levee management, sedimentation. All of these different things can be studied with this project. So irrigation water budget, international water budget, dam release events, levee and sedimentation, and endangered species. All of these can be covered with one model. And if you maintain this as a living model and you give access to all of the agencies to this data, you can see that it can be a very useful tool. And it can be updated and maintained relatively easily now that QGIS is available. When we first put this model together, we didn't have a very good levee development system, but we have since adapted our tools to make adding channels and levees really easy on this system. So I think that this is probably one of the easier models to create and maintain, and I think it runs faster than other than HEC-RAS. If you had this exact same model in HEC-RAS, it wouldn't, FLO-2D is going to outperform it as far as how fast it runs. So I think it's an excellent tool for assessing these long reaches of river. Now, let's move on to exactly what it would take to get levee data for this purpose. So I'm going to start with just some information over here about the National Levee Database. Let's see, I wish I could zoom into my area of interest. I think I reconnected my map. So we are somewhere in here, I believe, is our area of interest is somewhere in here. And I even have a, let's undo that. I even had a shapefile that I added. So let's see, add data. We'll add a shapefile. Here's our area of interest, and not exactly sure why you can't like right click and zoom to that, but you can't. Maybe you can, and I'm just not figuring out how to do it. But it's somewhere in this area, in this Valencia area. Okay, I think I can see it right there. Right, so if we take off levied areas, we can see our area of interest right here. So this is the Army Corps' levee database, and you can come in here to see the levees, to see what data is available. You can, what is this guy going to do? You can download the levee data as a geo package. You can download the levee data here as a geo package or GeoJSON or CSV, whatever you want. Or you can connect to the levee database using the Access Data Services, which I think should be right here. And we're going to show you how to do all of these things, but first I want to cover what happens when you don't have all this excellent public data. All right, so let's start back over here, and let's just set a couple of scenarios up. So let's say if you're not in the United States, you don't have this good levee database, you have low resolution DEM and no survey data. Can you still build a levee that's meaningful? And the answer is absolutely. Because typically speaking, levees are, sorry, wrong one. Levees are relatively easy to find because they typically are maintained as a roadway, as a service road. So they are relatively easy to find. I'm going to turn off the two levees right here. As you can see right here, it's pretty easy to see that that is the levee. So you can use that to build the alignment of your levee. And levees, depending on the purpose of your study, levees do not necessarily need perfect crest elevation data in order to get a valid study, okay? So we're going to show you two scenarios, but of how you can generate design levee data or just cutoff levee data. But we're also going to talk about what are some of the things that you need to do to make sure that your levee data matches your project and is functional. All right. So let's talk about, let's set a example, what is the purpose of your study? So if you are interested in design levee in order to protect property, then you are going to need to consider flooding from the riverside and flooding from the land side. So if you're doing a design levee, you need to make sure that you're running a effective land model that's going to be flooding, rainfall runoff that's going to be running and need to come up to your levee. Is that going to cause flooding to your people that you're trying to protect from the riverside? And then you do your river study, same thing, you're going to do your river study, and is your levee protecting those people from your riverside? And from those maps, because it's a design study, you don't really care about the crest elevation of the levee, because you have a water surface elevation that's going to be coming from both the land side of that study and the river side of that study that you can then use to give a to get a design criteria for your levee. Okay, so that's one way to think of levees. Another one might be levee degradation. So as this levee ages or is possibly damaged or is degraded, what about a levee fragility curves to assess where this levee is going to flood? So if you have a degraded levee in a certain area, you can give it a fragility curve that will flood at a given depth or a given depth and a given velocity. And you can set up those fragility curves to breach that levee at a specific rate at a specific spot. That's a pretty common method of modeling on both the Rio Grande and the Mississippi Valley. What about overtopping? So if you have a levee that's already in place and you want to study overtopping, then it's very important that you get the ground elevation, the river capacity, and the levee crest elevation correct. So you're definitely going to need some survey elevation for that or some LiDAR data, which is what we're going to show you in the next video. We're going to do bad data sources in the first video and good data sources in the second video. And then, do you want to model breach? Do you want to model levee breach? And if you do want to model levee breach, how are you going to choose your breach points? It's usually based off of engineering judgment, but you can also base it off of your water surface elevations, your depths along your levees, and things like that. You can also just breach it in spots and then run and breach it in a spot and see where that water is going to go, and then move downstream, breach it again, see where that water is going to go. You can do that as well. You can do all of these studies and you can set them up pretty quickly and then just send them out to run on their own while you're working on the next study. So that's pretty easy to do. Sensitivity analysis or breach studies, things like that are actually pretty easy to do. So the type of mapping that you want for any of these kind of projects would be depth maps, water surface elevation maps, velocity maps, levee what are they called? Levee deficit maps, and possibly impact and shearing maps and things like that. Other things to consider are when you're talking about modeling a levee, you have to consider crossings and points of contact between the two sides of the levee. So do you have a railroad crossing? Do you have a culvert? Do you have an irrigation head gate that is either open and closed in different seasons? Do you have do you have a flap gate through that levee that's open or closed in different seasons? Or do you have some kind of flood management system that would allow water to get, and it's not so much important up here because this is pretty flat, but if you come down to other parts of the Rio Grande, you can get some pretty good water kind of coming down off of the watershed and into the river valley. And if that water can't get to the river because of a levee, then you have problems, because you're going to be flooding the farmers that are on the protected side of the levee from the land that's upstream of them. So that's considerations that you might have. Okay, so AOI should take that into account. Your area of interest should take that into account. Okay, let's get back here to our project area, and we're going to start just with how to set up 2 no survey levees. Okay, let's turn our user levees back on. So these down here are going to be high resolution levees where we're going to be using that database from the Army Corps, and these up here are going to be low resolution levees where we're going to pretend that we don't have good elevation data for this site so that you can see how to make effective levees that would, that can help you analyze your process. So let's start with levee alignment, because that's what these guys are here. These levee lines, they are aligned to the top center of the levee. So if you edit this layer and you add a line, you can start to build your levee. Now I'm not gonna overwrite this, but I'm gonna follow this. I'm gonna show you how we make this levee. Okay, so we see that the top of the levee is pretty much this roadway right here, possibly a little bit larger over here. So we can take that roadway and even start. We don't even have to start on our project. I think we can even start up here off our project, and we can grab that whole levee. Now this is a 200 foot by 200 foot grid system, so the alignment does not have to be perfect. The smaller your grid elements, the better your alignment needs to be. So what we can do is we can just kind of come in here and get that general position of that levee, because we're not gonna be sampling any elevation data or taking any survey data or anything like that. So we don't have to be perfect about our placement of the levee. And you can see, as you can see, you can pop one of these levees in real quickly. And you don't have to be careful with how many vertices you're adding or anything like that. And I think what's happening here is that our levee is actually getting over into these trees a little bit. And I know that just because I know what that LiDAR data looks like. And you can see how fast this is going. And I'm not trying to be careful or anything. I'm just trying to get this alignment close. And I also think that there's 2 levees here. There's this one here that you can kind of see, and there's this one, and there's another internal levee here for some reason. Maybe this one was degraded or something, or degraded. I don't think degraded is a word, so apologize for that. And I'm using the arrow keys to navigate my map, or to move my map. Okay, so you can see that I can get through this levee really quickly. I'm almost done with the whole project, or with the whole project length. And that was the end where I stopped, but of course the levee continues on, so if you wanted to do the whole thing, you could just get it. And then of course, once you're finished with that, you're going to right click that line, and you are going to make your decision right here. What kind of levee do I want? And I'm going to write delete me as my name, because I want to delete this one because I already have it, but I want my crest elevation to be 9,999, or just add one more 9 there, because we do not care about the crest elevation of this levee. We do not expect it to be overtopped. It's a design feature. We don't need a correction or fill or fail elevation or anything like that at this point. We just click OK. And once I go into the levee lines, you can see on my attribute table that that is a new feature right there. So I'm going to go ahead and delete that feature because I just wanted to show you how easy it was to build a levee. And so let's go ahead and delete that, and let's just get back here to our 2 levees, or I guess our 3 levees that we have, that our area of interest will do. So okay, so once you build your levees and you've got your levee alignment down, you can then save this layer, and and then you can run the Levee tool. So the Levee tool for these guys is very simple. You'll just come here to the parameters tool, and this is just a drop-down menu for all these various tools, and we want Levee tool. And so we're not going to use, we don't have elevation, we're not going to use the elevation polygons. There aren't any elevation points yet, we'll do that later, and we just have user levee lines. Now what we don't have is, and we can also import 3D levees, which you say these are 3D levees, but it's really just XYZ data. XYZ point data is all that is. So we can also do it that way, but right now we're just going to use the alignment. So if I click and create those schema levees, and then it's going to tell me that there's one redundant levee that also has another levee in the same cutoff direction. Do I want to delete that? Yes, I do. And now it's telling me that there are 428 grid elements with levees and 1,054 levee cutoff directions and 0 failure data. Now let's take a look at what that made in our FLO-2D model. If we go to our FLO-2D model, you can see that the red lines are our FLO-2D lines. Now let's get to these two, let's get to this area. So I'm going to zoom to that area. All right. Now if I use the ID tool in here on my FLO-2D levees, let's see if it'll work. I think I can just do it this way, or I can do it this way. And then I use the ID tool and I can click on one of these, and you can see that that crest elevation is 999. So that there's no way that water can get from one side to the other of this levee. Now let's go check the other levee that we set to a 10-foot crest elevation. So let's zoom into these levees instead. So I'm going to select these two levees and zoom to those. And then we'll zoom in to these guys, and let's see what's happening over here. So now what's happening over here is something slightly different. If I ID this guy right here, this FLO-2D levee, you're going to see that it has a levee crest elevation. So, and you're going to see that this one has one that might be slightly different. Okay. So what we have here is a 10-foot correction. And what the model does with this correction is, if this field is null and this field is set to a height, a correction is actually a height. You know, if this was set to 10 feet, then this would be 999 plus 10. If this was set to -10, this would be 99.99 minus 10. But if this is null, then it's going to trigger a different processing system. And what's going to happen is it's going to assess your grid elevation on either side of your levee, and it's going to use that to define the crest elevation of your levee. All right, so let me show you how it works. So we're going to take this one right here, which is 4786, and then we're going to use this tool to assess the elevation on either side of this cutoff direction. So this is, we're just going to focus on this, 75.3218, and this is 76.2852. So our crest elevation right here is going to add 10 to the max of these two numbers. Okay, so you can see here that our crest elevation is 4786.2852. So now, because we have really high resolution LiDAR data, that might not be the best method, but if this was a DEM, or kind of, you know, they're like a lot flatter than high resolution LiDAR, then you would see that this would be a really good method for low resolution DEM data, because your levee would look, your levee profile would look relatively uniform, you know, from upstream to downstream. But let's take a look at levee profiles, because we do have a levee profile tool, and you can kind of access it here. So you can use your schematized profile, and then you can use this button, FLO-2D info, and you can select the levee. And what it will do is it will assess, it's not just assessing levee lines, it's assessing the levees here too. So what it will do is it will assess the levees that are kind of close to it. And now if I set my, this is the schematized data, the schematized levees, okay? So if I set this to levee crest, you can see that this is the levee crest along that line. So you can see it's not the best, but they're not off by much. You know, they're only off by a couple of feet. If you really focus on this table, they're not off by much. So if you found one that was really off, you would probably want to go and resolve it and fix it, but for the most part they look pretty good. Now if you want to assess the levee with respect to the raster, like again, that's high resolution raster, so you're not going to want to do that if you don't have good data. But if you do have good data, you can use this raster and you can assess this levee alignment along this raster. So here's levee lines, we're on levee lines, and here's the profile tool. This is a this is a QGIS plugin. So I'm going to click on this guy, but then I'm going to move it and I'm going to kind of share it with this window right here. Then I'm going to add, whoops, wrong one, sorry, that's not a raster. I'm going to add the raster, and I'm just going to change the color because I don't like red. It just makes it kind of like we already use red for our levees. Now I'm going to use I'm going to change from a temporary polyline to a selected polyline. Then I'm going to select this layer and then click the polyline to see some problems with my alignment. Okay, so first of all, let's zoom out. Now what you can see here is this is the polyline. The polyline ends right there and goes up in that direction. So it's a pretty long polyline, but you can see that maybe I have a bit of a problem right here with my alignment, and maybe have a bit of a problem right here with my alignment, but I don't really care about that because when I'm using the high resolution alignment, I'm going to show you some tools that are going to, you know, that are going to make it to where you don't have to care whether or not that alignment is perfect, because you're going to use tools that are going to capture the high elevation in that area, and it's really easy to do that. But for now, let's just focus on low resolution data. Okay, so low resolution data. Now the very last thing we want to look for is like holes in your levee. Okay, so if you have a hole in your levee, then water can leak out of it. So what we want to look, and we'll turn off our levee lines, and let's turn off everything else too. Let's just turn off these two guys, and we really just care about the grid. Now this levee right here should actually probably be right here. So there is a hole in the levee right here. So we do want to make our levee line, we do want to modify that so that it's actually ending right here. So we'll do this, and we'll add this guy, and we'll just put this right here, and that should do the trick. Let's save it. Now let's recalculate our levees, and okay, and there we go. That fixed that, and that's perfect because you don't really want a levee like along a boundary, but FLO-2D will ignore those anyway. Let's get rid of these guys, and let's get rid of this guy. Okay, so that fixed that hole, and we'll turn this off until we need it. And now what are we looking for? We're looking, first of all, we do not want our levee to cross our channel. Let's get rid of these channels right here. We don't want our levee to cross our channel banks because that would effectively take our levee out. So we want our levee to stay outside of our channel banks. And we don't want any holes, like if this were deleted, we wouldn't want a hole right there, okay? Everything looking good so far, but I do know that I have some places in here where my two lines might not perfectly align to my channel, or perfectly line up. Now it looks like it's fine. I didn't see any problems with that one. We can check this one. And again, I did have some problems here where my levee was actually crossing over like right here, and so I did have to make an adjustment to my levee right here. I had to move it outside of my channel. And I don't know what this little guy is doing here. Let's see, why is that little guy looking like that? Oh, yep, so that's actually like that. So we just leave that one as is and keep going. So I don't see any holes in the levee, but you know, if you run a flood model and you get holes in your levee, you're going to know right away. So like this levee right here isn't doing anything. See, there's no grid element right here. So that one would actually just be ignored by, it would actually be deleted or ignored by FLO-2D because it's blocking a boundary. So that would cause errors if it was overtopped or something. So that one's just ignored or deleted by the FlowPro engine. And then I don't see any issues here other than the fact that, you know, we missed all of that other levee up there because I haven't put it in yet. So that's how I would check a levee. And then the very last thing that I would do is I would run the model to ensure that the levee is the data is set up correctly. But I'm not going to do that right now because I want to go into the second video, which will be using high resolution resources. So what happens if you do have good elevation and levee data? How can you use that to your advantage? So that'll be video number 2.